Hello, my name is Yusuf, and today I'm going to talk about the physics behind the piano instrument. We got a piano right here. The piano is one of the most popular instruments used to date. It has many classical and contemporary uses. The modern piano is thought to have been invented somewhere between 1698 and 1709 by Bartolomeo Cristofori of Padua, Italy. The piano's home is thought to be Italy, which is also the place from where the most classical and expensive pianos currently are manufactured. The piano is one of the most complex instruments, containing over 7,500 pieces. The piano began to become publicized by Johann Bach and then later played by Mozart, who was the first concert pianist in the late 1700s. In the pre-Mozart era, which is the early 1700s, the piano had a major configuration. About 100 years later, the grand piano was invented. Both the upright and grand piano use the same technique to produce sound. However, the placing of some tools are in different positions. This piano right here, currently demonstrated, is the grand piano. First of all, there are 88 keys in a piano, ranging from lowest to highest pitch from left to right. The keys on the left cause vibrations in the longest and heaviest strings, while the keys on the right cause vibrations on shorter or lighter strings. The way a person plays the piano is simply by hitting the keys. When a piano key is pressed, a hammer flies up and strikes the strings, tuned to produce a corresponding note, then falls away from the strings quickly so it does not stop the vibration. Then the damper, which is a block of felt, falls down on the string to stop the vibration and the sound. This here is a demonstration of how these two mechanisms work. Here you can see a piano player playing the same key over and over. As the key is hit, the hammer strikes the strings and the damper rises. As the piano player puts his finger off the key, the damper falls back down to cease the sound. This right here are the strings and the soundboard. The soundboard amplifies the sound caused by vibration in the string. The longer the string is, the lower the pitch and the frequency of the waves. The shorter the string is, the higher the pitch and higher the frequency of the sound wave. All of these strings carry sound waves at the same speed. The speed or frequency of the wave for a certain string or note may change if the piano is off tune. This can be because of humid temperatures or very cold and dry temperatures. Piano tuners can fix off-tune strings by changing the tension of them through the tuning pins. Since each string is supposed to emit a certain frequency of sound wave, a tuner can use an electronic device that emits a sound wave of that string's frequency, then hear for beats. With this technique, a piano can be accurately tuned. By adjusting the tuning pins which the strings are attached to, the pitch of the string can be changed. The tenser the string, the higher the pitch, and the less tense the string, the lower the pitch. Beyond the strings, you'll see the cast iron plate. The cast iron plate pretty much maintains the pressure from the strings. The vibration of a piano strings alone would be too quiet to be heard, so their sound must be amplified. Piano strings, like the violin or the guitar, they all press down on a bridge, which conducts their vibration to a large piece of wood called the soundboard. So the wooden ribs glued across the board underneath help spread the string's vibration throughout its mass. Generally, the bigger the piano is, the more full and rich the sound is going to be due to higher amplification. This is why grand pianos produce such a richer sound and fuller sound. The sound waves are able to resonate throughout this whole open area. The lower pitch notes, which use the strings on the right, are very resonant, so to balance this out, for the middle and high pitch notes, 2 or 3 silver strings are added, as you can see on the left. Here is a demonstration of the sound frequencies caused by each note. The note at the very left has a frequency of 27.5 Hz, and the note on the very right has a frequency of about 4,186 Hz. Now for the pedals. The pedal on the left is called the Uno Corda, the one in the middle is called the Sostenuto pedal, and the one on the right is called the Damper pedal, and each have different uses. This is an example of the damper pedal, the most commonly used pedal. What it does is pretty much lifts all the dampers up off the strings and allows the strings to vibrate freely, resonating fully. This allows the sound wave to last longer. The pedal on the left shifts the hammers over two strings, so only one chord is hit. This is why it's called the una corda. This creates a soft and dampening effect. The sostenuto pedal does a similar thing what the damper pedal does. So when it is pressed, only that key when it is pressed, the damper rises up and all the other ones fall down. So it would be a similar effect as the damper pedal, but it only applies for one key. So overall, the piano is a percussion and a string instrument. It is very unique, and there are not many other instruments that are too similar to it. If there had to be two, they would be the xylophone and the keyboard. With the xylophone, there's a couple of key aspects similar to the piano. In the piano, the strings, and in the xylophone, the metal blocks are very similar, in the sense that the longer the metal block or the longer the string, the lower the pitches, and the shorter vice versa. The sound created by the piano is truly unlike to any other instrument. Although it is a half member of the string family, it does not produce that stringy sort of sound that a guitar or violin would. With the percussion instruments, it clearly does not sound like a drum set. What comes out of the piano is a unique, rich, and full sound created by the work of the soundboard, strings, hammers, keys, and dampers. If there had to be one instrument that would produce a similar sound to the piano, it would be the xylophone due to its similar construction. The physics behind the instrument is very intriguing, and the instrument is very fun to play, so I completely recommend it. And I'm done.